Hello everyone, and thanks for watching Edupedia World videos. I am Manish Agrawal, and today we'll continue with our topic of mole concept. Alright, so in today's session we'll finally start with what is the meaning of mole and how do we use that term in our calculations and in the chemistry as a whole. Right, so what is mole? Well, mole is nothing but a numerical number. Alright, for example, when I say a dozen is nothing but it is a numerical number. Dozen means 12. When I say that you have a dozen pen, it means that you have 12 pens. Alright, when you say that you have a dozen mangoes, it means you have 12 mangoes. Similarly, one gross means 144. One score means 20. Alright, so 1 dozen means 12. 3 dozen means 3 into 12, that is 36. 2 dozen of something means 24. Likewise, mole is also a number. It is used to refer to a bunch of particles together. Only difference is the dozen, gross, score, all these numbers are small. Alright, all these terms are used to represent a bunch of small number of particles, whereas mole is used to represent a bunch of very large number of particles. Okay, so exact value of mole is, for our purposes, we'll always take mole to be 6.022 multiplied by 10 to the power 23. Alright, from here itself you can see how big that number is, how big the bunch of our particles should be to call it a mole. It is 6.022 multiplied by 10 to the power 23. Alright, so there will be 23 zeros after last digit of that 2. Alright, so 6.022 multiplied by 10 to the power 23. Right, so it will come out to be 6022 00000 so on 20 zeros. Alright, so this is what we mean by mole. Okay, so once again, mole is not a measure of mass. Alright, you can never use mole to refer to mass. For that we have kilogram and gram, okay, or pound. And mole can neither be used as a measure of volume. For that we have liter, milliliter, meter cube. Alright, so mole is just a measure of number of particles. Okay, and it is a number. For our purposes, we'll always remember mole is just a numerical number, and it is always equals to 6.022 multiplied by 10 to the power 23. I keep repeating this number because you have to memorize it. Alright, this number you have to remember it, and more you listen to it, more you use it in your questions, more you will be able to recall it when you need the number mole. Alright, so let's go into further detail what mole is. So mole is also called Avogadro's number. Okay, so Avogadro was the name of the scientist, and the mole is called Avogadro's number. It is often represented by Na, capital N, capital A, but this is not a standard notation. Alright, so you can use your own notation for representing mole. And in units and measurement, it is abbreviated as MOL. Now this is a standard notation. Like kilogram is always represented as K and G, kg. Okay, and gram is represented either as GM or simply G. Mole can be represented as MOL. Okay, mole. So when I say I have 1 mole students under me, okay, it means I have 1 Avogadro's number students under me. So 1 Na is equal to 6.022 multiplied by 10 to the power 23. It means I have these many students under me right now. Alright, so now you know what a mole is. Let's see it from a numerical point of view, what this signifies for us. Okay, so in a previous session we calculated number of atoms present in a molecule. Okay, if you remember, I had given you the example of glucose. Okay, we took the example of glucose and we saw in glucose one molecule contains 12 atoms of hydrogen, 6 atoms of carbon and 6 atoms of oxygen. Alright, so then I ask you to calculate how many atoms of oxygen are there in 1 dozen molecules of glucose. Alright, so 1 dozen molecules of glucose will have 12 into 6 atoms of oxygen. Why? Because 1 dozen has 12 atoms and 6 is the number of atoms in one molecule. Alright, we solved this using unitary method actually. Okay, let's see it again. Say the question is calculate number of carbon atoms. Calculate number of carbon atoms in 3 dozen molecules of glucose. In 3 dozen molecules of glucose. Alright, so if you remember what we did to calculate carbon atoms, first we calculated what 3 dozen means. Okay, so let's see that again. So 1 dozen molecule of glucose implies, okay, 1 dozen means 12 molecules. Okay, so 3 dozen would mean how many molecules? Let's say x, then you cross multiply, so x will be nothing but 12 multiplied by 3, that is 36 molecules. So actually the question becomes how many carbon atoms are there in 3 dozen molecules of glucose. So it is how many carbon atoms are there in 36 molecules of glucose. Now we again use unitary method. We know that 1 molecule of glucose contains 6 atoms of carbon. So 36 molecules of glucose, alright, I won't write it again. 36 molecules of glucose would contain, let's say, x number of atoms of carbon. Now we cross multiply. So unitary method gives us our answer that x is equal to 6 multiplied by 36. This is molecules divided by 1 molecule from left hand side. So this gives us the answer 6 multiplied by 36, that will come out to be 216 atoms. Okay, so you might remember that we solved this question that 3 dozen molecules of glucose will contain 216 atoms of carbon. Alright, so similarly, if you are asked how many atoms are present, okay, how many atoms of carbon are present in 1 mole of glucose. Alright, so 1 mole of glucose will have how many atoms of carbon? So first, what do we mean by 1 mole? So 1 mole of glucose, that is 1 mole of C6H12O6, implies 1 Na. Alright, Na, the Avogadro number. So 1 mole means 1 Na number of molecules. Okay, so that is, in other words it implies I have 6.022 multiplied by 10 to the power 23 molecules of glucose. Okay, so the question now becomes how many atoms of carbon are present in 6.022 multiplied by 10 to the power 23 molecules of glucose. So we already know number of atoms in 1 molecule of glucose. Again, using the unitary method, 1 molecule of glucose, okay, 1 molecule of glucose contains 6 atoms of carbon. So Na number of molecules, that is 6.022 into 10 to the power 23 will contain how many atoms? Let's say X. Now you cross multiply. So what do you get? X is equal to 6 Na. Alright, what do we get? X is equal to 6 Na. That is 6. Okay, that is 6 multiplied by 6.022 into 10 to the power 23. Okay, so this is approximately 36 into 10 to the power 23. Okay, if I ignore the digits after decimal, so it becomes approximately 36 multiplied by 10 to the power 23 atoms. So these many atoms of carbon need to be present to have 1 mole of glucose. Okay, so now you have an understanding of this. Let's see it from a different perspective. Okay, so what if my question becomes, what is the number of molecules of water if I initially have 1 mole of water? Okay, so my question is, now I have not been given the molecules of water. I have been asked what is the number of molecules of water if I have 1 mole of water. Now it's a pretty straightforward answer. Okay, we know 1 mole is nothing but equal to Avogadro's number, that is 6.022 multiplied by 10 to the power 23. So I will have 6 into 10 to the power 23 molecules of water. Alright, so this is the answer. Now let's change it. Okay, let's reverse the question. Now the question is, what is the number of moles of water? Alright, or how many moles of water, this was question 1, this is question 2, and question 2 is how many moles of water are present with me in 1 molecule of water. Okay, so question is, if I have 1 single molecule of water and I want to represent that number by the term mole, okay, using the term mole, so how many moles of water will I have if I have only 1 molecule of water? Alright, so we have to do the reverse of what we did in the first question. In the first question we were given 1 mole of water and asked how many molecules are present. Okay, so we knew that 1 mole contains 6.022 multiplied by 10 to the power 23 molecules. Now the question is, I have 1 molecule of water, so how many moles does it have? Alright, so to represent it in terms of mole, let's use the unitary method. So I know that Na number of molecules. Alright, I know that Avogadro number of molecules together form 1 mole molecules. Okay, so it means 1 molecule will form, let's say, X mole of water molecules. So what is X? I need to cross multiply, right? So 6.022. okay, we are writing Na as 6.022 multiplied by 10 to the power 23. So this into X is equal to 1. 1 mole multiplied by 1 molecule is still 1. So X is nothing but 1 divided by 6.022 multiplied by 10 to the power 23, or it is 1 divided by Na. Okay, so 1 single molecule means 1 by Na moles. Okay, it's quite straightforward. So if I have been given 5 molecules of something, okay, so 5 molecules of, let's say, water, so it means I will have 5 by Na, 5 divided by Na moles of water. Okay, now since I know this, I can also calculate number of hydrogen atoms and number of oxygen atoms in this molecule. So now we are clear with this. Let's move on to the next thing. So now we have a more clear understanding of what mole is, right? So when somebody says that I have half a mole of pen, okay, I have half mole pens, so it means that person has 0.5 mole pens, okay, and 1 mole is Na, so half mole will be Na by 2, okay, so that is 6.022 divided by 2 multiplied by 10 to the power 23, so that is 3.011 multiplied by 10 to the power 23 pence. Okay, similarly you can have 0.25 mole, okay, 0.3 mole, 0.4 mole, any digit can be present in front of the mole, okay, like you can have half a dozen things or you can have 2 dozen things, okay. So 0.25 mole. Now there is a common confusion among students here, that when I say 0.25 mole, doesn't that make my particle into pieces? Like I can have 1 mole of something, I can have 2 moles, but having 0.5 mole or 0.25 mole might be wrong, but this is a misconception. Alright, if you see the number here 3.011, how can you have 0.011 pen, right? But actually if you see here, it is multiplied by 10 to the power 23. It means the number is going to be whole number, it is not a decimal number. Once you finish multiplying that 23 zeros, you will have 3011000 20 times. Alright, so it is going to be a whole number. So you can have 0.5 mole, 0.25 mole, or even 0.33 mole of something. Okay, so let's move on to the next part. Now technically mole is defined by a different definition. Okay, technically mole is defined as the number of atoms present in 12 gram of carbon 12 isotope. What do we mean by this definition? Let's say you have a weighing machine, okay, and you have a lot of carbon 12 atoms, okay, not carbon 13 or carbon 14, you have the isotope carbon 12 atoms. Now you start putting these atoms one by one on the weighing machine, okay. So you have put your first atom. Initially the reading of the weighing machine will be 0, but as soon as you put your first atom, it will show some positive reading. Then you put on the next atom, then third, then fourth, and you go on doing that, okay, until the reading rises up to 12 gram. Okay. So now the weighing machine reads 12 gram. That is the total number of atoms that you have put on the machine has a mass of 12 gram. Now you stop putting any more number of atoms and instead you count the number of atoms that you have put on the machine. That number will always come out to be equal to 6.022 multiplied by 10 to the power 23. It means that 12 gram of carbon 12 atoms, okay, actually contains 1 mole of carbon 12 atoms. So that is why mole can also be defined using this definition, that it is the number of atoms present in 12 gram of carbon 12 isotope. Okay. So let's see what this definition actually mean to us in numerical form. Okay, so let's see this definition can actually be used to calculate the value of 1 AMU. If you remember from our last session, we said that 1 atomic mass unit scale or 1 U comes out to be 1.66 multiplied by 10 to the power minus 24 gram, and I said that you have to remember this number. Now I'll show you a way to calculate this number, how this number was derived. So if you remember the definition of 1 U or 1 AMU, it was 1/12 the mass of 1 carbon 12 atom. Okay, mass of 1 carbon 12 atom. Okay, So this will give me the value of U. So I need to calculate mass of one carbon 12 atom. Now from the definition of mole we have that 1 mole or 1 Na atoms of carbon actually weigh 12 grams. 1 Na atoms weigh 12 gram. So what is the weight of one atom? Okay, I need to calculate the value of X, that is weight of one atom, so I can substitute it here into the mass of one carbon atom. So what do? I cross multiply. I use unitary method. So this gives me that X is equal to 12 gram multiplied by 1 atom divided by 6.022 into 10 to the power 23 atoms. So mass of one carbon atom is nothing but 12 by Na gram. Okay. So mass of one carbon atom is nothing but 12 by Na gram. So that is 1 U. Okay. So that means 1 U is equal to 1 by 12 into mass of one carbon atom, and mass of one carbon atom is nothing but 12 by Na gram. So 1 U in grams will be equal to 1 by Na gram. Okay, 12 gets cancelled, 12 and 12 gets cancelled, so 1 by Na gram, that is 1 by 6.022 multiplied by 10 to the power 23 grams. This number, if you calculate it using your calculator or just make the calculations yourself, will come out to be 1.66. Approximately it will come out to be 1.66 multiplied by 10 to the power minus 24 gram. So 1 AMU or 1 U is equal to these many grams. So that's how this number was derived. So this definition could also be quite important. Okay, you just have to remember it. You have to remember 1 U, what is 1 U in grams, and you have to remember what is 1 mole. Okay, so you have to remember these three things. So now you have a better understanding of the meaning of 1 U. Alright, you know that 1 U is nothing but 1 by Na grams. Okay, 1 U is nothing but 1 by Na gram. So when I said that one oxygen atom weighs 16 U, what we actually mean that it weighed 16 by Na gram. Okay, when we said that one nitrogen atom weighs 14 U, how do you know that it weighs 14 U? You cannot know that. It is a standard information. Either you have to remember it, and basically it is always given in your questions. Okay, or you have to refer a textbook or the table of atomic masses to know the values. So one oxygen atom weighs 16 U, one nitrogen atom weighs 14 U. It means one nitrogen atom weighs 14 by Na or 14 by 6.022 multiplied by 10 to the power 23 grams. Okay, so this is what we mean by 1 U. So let's move on to the next thing. So next, another way of referring to mole. Okay, now you have to pay attention here because it can be quite confusing. See, 1 mole of particles can also be referred to as 1 gram particles. Okay. If you remember, I said mole is not a measure of mass or weight. It is not a measure of volume. Okay, and that still holds. We are not changing our definition of mole. 1 mole still means 1 Na. It still means 6.022 multiplied by 10 to the power 23. It's just that some people have given it another name. They have said that 1 mole of particles can also be written as 1 gram particles. Okay, why did they do so? It doesn't matter. You just have to remember that 1 gram particles means 1 mole of particles. Now another important point to be noted here is they didn't say 1 gram of particles. What they said was 1 gram particles. Right? So 1 mole of particles is not equal to 1 gram of particles. It is equal to 1 gram particles. So 1 gram atoms, it means 1 gram atoms means 1 mole of atoms. It means that 1 gram molecules means 1 mole molecules. Okay, so let's see this in further detail. Okay, let's see. So I just said that 1 mole also means 1 gram particles. Okay, 1 mole particles means 1 gram particles, and it is not equal to, okay, it is not equal to 1 gram of particles. Alright, this is important. 1 gram particles and 1 gram of particles are two different things. When you say 1 gram of particles, you are actually referring to the mass here. Okay, you are saying that you have so many particles that they together weigh 1 gram. 1 mole does not mean that. Okay, so this part we are going to exclude this part. Alright, for us 1 gram particles means 1 mole. So that means when you have 1 gram atoms of hydrogen, 1 gram atoms of hydrogen, it implies that you have 1 mole, or 6.022 multiplied by 10 to the power 23 atoms of hydrogen. Okay, when you say that you have 4 gram molecules, you have 4 gram molecules of glucose. What does it mean? It means that you have 4 moles, that is 4 Na molecules of glucose, and I can make the subsequent calculations about that. 1 molecule has 6 carbon atoms, so 4 Na molecules will have how many carbon atoms, and so on. Okay, so now we are clear on this. The next session will take further examples and further calculations on this part. Okay, thanks for watching Edupedia World videos.